Hi everyone, I'm Miles. Today we'll use examples to learn one of the most interesting concepts in economics, externalities. It explains why competitive markets sometimes fail to maximize social welfare and serves as a key theoretical basis for environmental protection and regulation. An externality is when the cost or benefit of an economic activity affects a third party. Extra costs to others are negative externalities, while extra benefits are positive externalities. Markets usually only consider private benefits and costs, but society cares about all costs and benefits. So we need a few core concepts. For costs, MSC is marginal social cost, MPC is marginal private cost, and MEC is marginal external cost, where MSC equals MPC plus MEC. For benefits, MSB is marginal social benefit, MPB is marginal private benefit, and MEB is marginal external benefit, where MSB equals MPB plus MEB. Regardless of the type of externality, the social optimum follows the same principle, MSB equals MSC. Let's look at negative externalities first. Suppose the demand function for shared electric scooters is P equals 700 minus 2Q, and the supply function is P equals 100 plus Q. Each rental causes $60 in external congestion costs. First, market equilibrium is Q 200 and P $300. With external costs, social marginal cost, MSC, is 160 plus Q. Setting MSB to MSC, 700 minus 2Q is 160 plus Q, the social optimum is 180. Consumers pay $340, firms receive $280, and this $60 gap is the Pigouvian tax. The market produces 200, but society only wants 180. This shows that negative externalities lead to overproduction and deadweight loss. DWL equals 0.5 times 200 minus 180 times 60, which is $600,000. How do we correct this? Impose the Pigouvian tax on the seller equal to the marginal external cost, which is $60 per rental. The government can also implement quantity controls or use regulations to reduce external costs. Now let's look at positive externalities. Suppose residents plant urban trees. The demand function is P equals 80 minus Q, the supply function is P equals 20 plus Q, and each tree brings $12 in external environmental benefits. Market equilibrium is found where 80 minus Q equals 20 plus Q, giving Q equals 30,000 trees and P equals 50. With external benefits, MSB is 92 minus Q. Equating MSB and MPC, the social optimum is 36,000 trees. The market plants 30,000 trees, but society wants 36,000. This shows positive externality underproduction and deadweight loss. DWL equals 0.5 times 36 minus 30 times 12, which is $36,000. The government can use a $12 subsidy, public planting, or greening standards. Finally, for negative externalities, MSC is greater than MPC, leading to overproduction. Solve this with Pigouvian taxes, quantity controls, or regulatory standards. For positive externalities, MSB is greater than MPB, leading to underproduction. Solve this with subsidies or public provision. The standard 4 steps. First, determine if it's a positive or negative externality. Second, establish MSC or MSB. Third, set MSB equal to MSC to find the social optimum. Fourth, calculate DWL and choose appropriate government policies.